Hello everyone, and we're here for our next video where we're going to put it all together. So we have generated our ground, we have generated our pebbles. So how can we efficiently put this all together? We're going to use a subcop node and use some specific attributes to drive the size and also the direction of our pebbles. And later on, we'll use a material style sheet to create a variety of combinations of shapes with different materials.
So first out here, let's place our camera, called the rendered camera. So that will be the point of view that we're going to see our shore. So we create everything for this camera. That can help us to optimize resources since we don't need to create anything else that we don't see. If you have an animated camera, you may take in consideration everything that's going on the whole animation. And if you don't know, well, you have to create everything. And let's generate here what will be the container for our rocks. So dive inside, we want to bring in, to merge the object of the ground that we created before. So we use the out ground. And that will be the base for use my favorite node of all. That's going to be the sketching point. But before, let's painting the attribute that we want for this. So we're going to paint where we want the rocks or the pebbles. So create this attribute called rock. And now we can just go over the geometry and just paint this over there. And that allows us to have a lot of control of where we see, and even using the different values of this attribute to drive how much, or the amount of density we are having in one area. So see, as far I go away, I'm reducing that value. So now we're just plugging in the sketcher node, my favorite node of all. I don't know why. And use the rock attribute that we just created to drive the density attribute. And you can see wherever we had painted that attribute, we have points scattering around there. So that's going to be a base for instancing of those objects there. So let's see, we're always ready to jump in and get some result there. So I put a file node so we can bring the rocks, the pebbles we created before, and I also use a cop node stamp, so you copy that geometry for every single point that we generated. So let's plug this there, and of course we're not seeing much because there is no file there, but just for illustrate, like let's connect here a sphere. And you're going to see a sphere being copied over every single point. If you reduce, you already get the idea of what we are trying to do here. So let's bring our rock to the file node. I got our first one, our first instance, and you connect there, and right away you're going to replace all the spheres before to this rock. Remember, rock was quite big at the beginning, but one thing to keep in mind here is the memory use. You see 1.66 gigabytes, that's quite a bit, while we're copying 50,000 rocks. So what we want to do to reduce this is use what we call a pack geometry that we are reading from disk. And we can show this as a full geometry, so that nothing changes, but see the use of the memory, it comes down quite a bit for 34. And that happens because Houdini is just loading one geometry and instancing this over. Well, let's make them smaller, like 0.5, or even smaller than that, 0.20, 25. And nice, we have plenty of pebbles all around there, but they're all the same. And we can change here as it change the file name, but they'll still be the same. Also, let's start randomize some of these attributes. And what we want to do is we're going to add some attributes that the cop node, the cop sop node already is looking for it. So the first one is going to be the scale. So it has one called a pscale. And of course right now, as soon as you create this, it's looking for the value of 0. So that's why all the pebbles disappeared. But let's add a randomize of this attribute. And that will allow us to have different sizes. And I'd say it again, it's pretty cool that the cops SOP node already is looking for this attribute and doing its job. And so let's change the attribute name for the pscale, and let's make it between, I don't know, 0.8, 0.75 to something like 0.25. All right, you already can see a little bit. Let's push this so just we can feel more. Let's put it 0.5, and we can notice that randomly we have stones that look in different sizes. But they all seem well organized to point to the same direction. Not something that we would notice on nature. And I'm sure if you bump on that, you would start to think that alien civilization stopped by and organized all those stones. So let's add the same thing for the rotation. So we added the ROT attribute, the rot. And the same thing, the cop SOP is looking for this attribute and identifying this, they will be rotating this. So of course rotation is a vector, since we are using this in all three axes. And we are created in a 4-dimension because also we tell which one of axes we are rotating. What is not a big of a deal. So rotating is -180 to 180. That's almost be a full rotation. And you can see automatically you're ready to have like a massive randomness. And even if we are dealing with only one type of rock, we don't see much of the repetition here, right? We actually got in a very good position for this. But we also want to use the other ones that we created. And for that, we want to create one more attribute for control this. So let's go and create attribute and add one more. And this one we're going to use is slightly different, right? And we're going to call this type. The SOP node, the cop SOP is not looking for this. We'll call it this instance because it's the object that we are instancing. So it's not looking, so it doesn't know what to do with this attribute. And this will be an integer, because remember, or we can import the rock 1, 2, 3, 4, 5 to 10. There's no rock 1.5. And we're going to add a randomization on top of that. So going to be a instance rot, and actually let me type it correct, instance, and let it go there and change the attribute for instancing on top. And this one we want to go 1 to 10, because that's the amount of different pebbles we had created there. So we can add the minimum value 1 and the max value for 10. And now we need to go back to the copy SOP and go to the stamp tab and allow it to do a stamp. It's pretty much for every single point it's getting, it's creating a stamp for this. So it's going to read this attribute we create, the at instance, so we read it as a global variable, and then go to pass along this variable to the object is copying. So now we can use this inst that we just create to drive the file's opening. So I use here the tick marks here to be on the text form, the string form, and that reference to that cop node. So I use the function stamp, and here we're only putting the node is looking for. So it's looking for the copy one that we just create, and now we have to tell which each attribute is looking. So it's looking for the inst that we just create. And we have to tell them if you don't find any value, which one to drop there. We put a 1. It's going to find for everyone anyway. And now start cooking, calculating all that. And we randomize this for all these different pebbles that we created to populate. And we have like 50,000 rocks and only using 32 megabytes of memory. That's pretty efficient. So let's push this even more. Let's reduce the size of those rocks for 1.8 to become very small. So that's a global, right? So every single one is going down. This, even if we're scaling them afterward. And just so we can get a render, we can see the volume. Let's add an environment light here because it's always fun to render. Actually, that's our ultimate goal is render. So I put here environment light so we can, and let's see it. Of course, we don't have any material on the top, but it started looking pretty good. I'm very happy with the result that we're getting. And let's create the materials for this rock. Once again, I like to keep everything in one place. So I put this under the sop rock. You can put this under the material tree or whatever you want. And let's create our first material. We're using 4 different maps. That's what I have, different maps for the rock. Let's call this rock 1. And if you go to the texture file, let's make sure you have this alt set to on, because that is a multiplier. So I multiply by 1, so the color keep the same value there. And let me bring here some of the maps I have. I'm gonna use their having a sequence like rock 1, 2, and 3. So let's use rock 1 base color. And after we're gonna use the rock 2, rock 3, and rock 4 for each one of these assets, so create a nice variety on the color. So you see here, they are called rock 1. Also, let's bring in the normal map again. And I'm only going to use one for all the materials. If you want, you could create different versions of the normal. And let's put it up with the roughness so they don't not super shiny. But if you look here, rock 1, and the name also how we name our node. So let's do a trick here to save us some time. Let's put a $OS. So it pretty much is reference the name of the node itself. So we are using rock 1, and that name is going to be rock 1 there on the path, as we can see. So that's going to save us some time. As I copy this, press Alt and left button, and Houdini is automatically versioning up rock 2, 3, and 4, and that also automatically name our maps there. I love it. I love it when Houdini does my job. But don't tell anyone, right? So they keep paying me, thinking that I'm doing all the job when it's Houdini doing the job. But how are we going to assign this? That's a very good trick. We're going to create one more attribute afterward, after we have instanced those rocks. And we're going to call this material, right? So we have 4 different rock materials, and so we're going to have this attribute going 1 to 4. So create the material attribute. Once again, I use a randomize attribute to drive this 1 to 4. And we're going to use this in connection with the material style sheet to be a conditional. So as we're looking for this, that has been randomized over there to see what material is going to apply later on. So we create here a good combination. We can have as many different shapes we want and also materials. So let's go for the data tree and the style sheet, and you go to the rock, and you're going to create a style sheet form. And here let's create our style. So add style, and create our first one. We call this rock one. Now you need to determine how it's going to drive this. So our target is going to look to the primitives, every single primitive that we have there. What will be the condition that will be triggering that style? Well, we're going to look for the point groups that's coming out of there and look for that material attribute. So say the material attribute is equal to 1. So I'm not assigning a value there, so that's why I had a double equal. We're going to trigger this override. And that's going to be a set material. So it's looking for the material, and now we tell there on the value which material I want to assign. So you go there on the one we created, rock 1. And it's that simple, and you can use it for so many things this, to create so many random and variety, and we can also tag on and off those styles. So it is a very useful tool. So of course we're going to duplicate this for all different 4 rocks that we are using, and then and after just of course change the parameters, so otherwise they will be all assigned for the same. So let's go to the rock number 2 or the pebble number 2 and change that for material 2. The same thing with the material, applying rock 2. And there's different ways you could do it. You could even use, instead of being setting material, you could be setting a parameter in material, and that be the map you're using. So definitely this way we would not need to duplicate the style. One style would drive everything. There's so many ways to go there. I'm just showing this technique here since we're dealing with a very fairly small numbers of map. So let's render and see how it works. Doesn't look like a whole lot has changed. Let me increase just a little bit of the lighting there because it was a bit overexposed, so it's washing everything out. And now we can see a little variety coming out of there. See, one is more gray, just like the maps we were using. You can see different rocks or different pebbles being assigned different materials. Pretty much out of the box on that. It's pretty nice. And you can use this, let's say we have a crowd and we want to create them with different dressings or different colors of t-shirts or even vegetation, and we have different leaves and you want to apply let's say colors on one leaf. It's a very powerful technique to use here. Well, I'm just gonna make those rock maybe slightly darker. I think they're too white, so let's jump back and let's use that multiply value that we saw before. Right, let's put it 0.5 there, so it'll be multiplying, making it darker. I definitely would tweak more of those colors and probably the maps as well, but definitely that can help us to get the idea of this technique here. So see, on a very quick way, we can get a result. That's it for this video, and that shows us how to use the scattering node with some of the attribute that they're using, that they're looking for, like the rotation, the pscale, and also how to use the material style sheet as a powerful tool to create a whole lot of variety on your assets in your Pebble. So we're going to finalize this series of video. The next one, giving the final touch, we added the vegetation and also the water. See you then. Take care.